Very good morning to all of you. Am I audible?
Good morning,
sir.
sir.
Yes, sir.
Good morning, sir.
Whether the screen is visible to all? Full screen?
Yes,
Yes,
sir.
sir.
Okay. Welcome back to the session of engineering mechanics. So today we will see the further things. What have we studied in the last class?
Free body diagram.
Yes, free body diagram. Before that one? Equilibrium. Correct. What is equilibrium? What is equilibrium? What it is?
When the number of forces keep the body at rest, the body is said to be an equilibrium.
Yes, it is equilibrium. Or another condition is when condition of the body is unaffected, even it is acted upon by the number of forces, then the body is said to be equilibrium. Okay, what is the condition? Mathematical conditions. When you are saying it is in equilibrium, what is the mathematical equations? Mathematical formula क्या है? Analytical method. Analytical condition for the equilibrium. Conditions for the
Condition of
equilibrium.
x is equal to 0, condition of y is equal to 0, and r is equal to 0.
Yes. What is summation of fx?
Horizontal.
Don't say only horizontal. It is algebraic sum of all the forces
Sorry,
along
algebraic sum
horizontal
of
direction.
horizontal forces.
Okay. Then sigma fy equal to 0 means it is
Vertical summation of vertical forces.
algebraic sum of all the forces along vertical direction is equal to 0. And r is resultant force is equal to, if sigma fx and sigma fy are 0, obviously r is equal to 0. Okay, so in the non-concurrent force system, there is one more term, that is algebraic sum of all the moments are equal to about a point is equal to 0. Okay, then in graphical conditions for the concurrent force system, vector diagram must be closed. Correct. For the non-concurrent force system, the funicular polygon must be closed. Okay, this one we have studied. Then coming to the body, free body. What is free body? Yes. Can anyone? Yes, anyone tell me what is free body?
When the body is separated from its surrounding, for considering the equilibrium of a body under force is called.
Yes. When the body is separated from its surrounding for considering the equilibrium of bodies under the force system is called a, it is a body. Means the body is not subjected to any forces. It is free from all the its surrounding forces. Then what is free body diagram then? What is free body diagram?
A diagram in which all active and reactive force as shown on the free body which is separated from its surrounding is called a free diagram body.
It is a diagram which all the active and reactive forces are shown on the free body which is separated from the surrounding is called as free body diagram. Are you getting the difference between the free body and free body diagram? सभी को समझ में आ रहा है? Free body में
Yes.
फ्री बॉडी में जस्ट बॉडी रहता, उसका कुछ भी प्रॉब्लम नहीं रहता. ओके, कुछ भी. Screen is not visible. Is it visible, everyone?
The screen is not visible, sir.
Not
Yes,
visible.
sir.
Okay. Wait a minute. Now, is it visible?
Yes, sir.
Yes, sir.
Then you should tell me. You should have tell me. Okay, whenever the screen is not visible, you should tell me.
Yes, sir.
Now, roll number 49, Rohini, Shruti, is it visible screen?
Yes, sir.
Okay.
Yes, sir.
Okay, thank you. Okay, whenever screen is not visible, you have to tell me. Okay, because the screen is visible to me when sometimes due to technical problem it may not be visible to you. Okay, at that time you have to tell me. Okay, so free body में क्या रहता है? Just it is a body. It is free from all the forces. In the free body diagram में, it is the body is subjected to all the kind of forces, active and reactive forces. Okay, then we have seen what are the active forces, force, applied force and weight of the body. So these are the active forces. And what are the reactive forces? The reactions offered by the ground, floor, string, rope, etc. Okay, these are the reactive forces. And we have seen examples also, correct?
Yes, sir.
Yes, sir.
Then we have studied Lami's theorem. So this is L-A-M-I apostrophe S, Lami's theorem. What it says, it states that when three concurrent force system keeps the body is in equilibrium. when a body is subjected to three forces, and those three forces are in concurrent force system, and the body is in equilibrium, then each force is proportional to the sine of the angle between the other two forces.
Sine of angle
Between the other two forces. Okay, so this is F1 divided by sin alpha is equal to F2 divided by sin beta is equal to F3 divided by sin gamma. Okay, in the last class we have seen this one, correct? So have you written this statement in the last class?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Derivation part you have not written, correct?
No.
Okay, you have drawn that space diagram and vector diagram. Have you drawn?
Yes, sir.
Yes,
Yes,
sir.
sir.
All of you have drawn, correct?
Yes, sir.
Yes, sir.
Okay. If all of you have drawn, then start writing. I will tell what to write. Okay, consider. Start writing. Okay, मैंने diagram बाद में draw करके I will start here. Okay, so वो diagram के नीचे लगी. Consider. Just you have taken the statement and diagram, space diagram and vector diagram. You have taken, no? Correct?
Yes, sir.
Okay. Next, write down. Consider the forces. Consider the forces. All of you write down. Forces F1, F1, F2, and F3 are acting on the body in equilibrium equilibrium stop. Since the body is in equilibrium, body is in equilibrium. Is it visible? Whiteboard?
Yes, sir.
Yes, sir.
Since the body is in equilibrium, the result should be the resultant should be zero. The resultant should be zero, which means that the last point of means that the last point of vector diagram all of you write down. Vector diagram should coincide with the first point A. First point A. First point A. First point A. Thus it means it results in a triangle. It results in triangle of forces as shown in figure. As shown in figure. Now alpha, the external angles, at points
Sir, alpha राहिले.
no, now the external angles, okay, no alpha, later on it is there. Now the external angles at points a at points A, comma B and C and C are equal 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 beta, comma gamma and alpha and alpha respectively and AB and AB, comma BC, AB, comma BC and CA are indicates the forces F1 forces F1, comma F2 and F3 respectively. Therefore, in the above triangle, triangle ABC, AB is equal to F1, BC is equal to F2, comma CA is equal to F3. CA is equal to F3. Okay. By applying sine rule to triangle, sine rule to the triangle ABC, we get F1 divided by sine of 180 minus alpha is equal to F2 divided by sine of 180 minus beta is equal to F3 divided by sine of 180 minus gamma. So this is nothing but F1 divided by sine alpha is equal to F2 divided by sine beta is equal to F3 divided by sine gamma. This is the derivation for Lami. So I will write draw the diagram so that it will be understanding. What is this for? This is F1, this is F2, this is F3. F1 composite angle alpha, F2 composite beta, F3 composite, F2 composite, F3 composite, it is gamma. This is space diagram, and this can be written as triangle. It is spectral diagram I can write. So F1 is in this direction. We'll write like this F1 diagram. Okay. Next, there is F2. F2 is in this direction. F2 is in this direction. We'll write F2. And 3 is in this direction. I will write like this. Okay. So next I will write all the terms. So F1 is in this term. So this is F1. F1 is here. This is F1. So in the vector diagram, this is F1. So this is term F2, and here it is in the F3. So angle F1 and F2 के बीच में कितना है अल्फा sorry gamma. This is F1, this is F2. So this is gamma. Then this is F2 force है ना, F2 and F3 के बीच में कितना है, F2 and F3 के बीच में अल्फा. Then F3 and F1 के बीच में कितना है, this is beta. Okay. Then all of you look at this triangle.
सर्कल वाले फिगर से क्या?
हाँ, second vector diagram. A point. This is F1 force is denoted by AB. F2 force is denoted by BC. F3 force is denoted by CA. Okay. So this एक straight line कितना रहता? 180 रहता. If exterior angle is that is gamma, then what about the interior angle? How much it is? It is 180 minus gamma. So this is 180 minus alpha. So this is 180
minus beta.
minus beta. Okay. So you have taken this diagram. Have you written up to this much? Have you written all of you?
Yes, sir.
Okay. I will explain. Concentrate. I will
1 minute,
explain.
sir.
Okay. So whatever I have drawn in the space diagram and in the vector diagram, this is space diagram. Okay. Space diagram, and this is
Sir, 1
vector.
minute.
Okay. Vector diagram. Yes. All of you have written?
Yes.
Yes, sir.
Yes, sir.
Okay. So the extra class I have told this one. Okay, space diagram, and this is vector diagram I have told. Okay. So this is one body is there. This is a body. This body is subjected by 3 forces. According to Saint rule, what it says, that if 3 forces are acting on a body and body is in equilibrium, the 3 forces should be concurrent. Okay, 3 forces should be concurrent. Body is in equilibrium. Then in that condition, each force is directly proportional to the sine of the angle made by the other 2 forces. Sine of the angle made by the other 2 forces. Okay, so this is a body. This body is subjected to 3 forces: F1 force, F2 force, and F3 force. Okay, F3 force. Consider forces F1, F2, F3 are acting on the body, and body is in equilibrium. Okay, body is in equilibrium. Since body is in equilibrium, the resultant should be what? What is condition? Resultant should be 0, correct? Huh? Everyone?
Yes. Yes.
Okay. Since the body is in equilibrium, the resultant should be 0, which means that the last point of vector diagram, should coincide with the first point A. See, this is the vector diagram. Okay, this is the vector diagram. It has started from A and it is ending at A. It means it is closed. So resultant R is equal to 0 means the last point of the vector diagram should coincide with the first point. Correct? No? This statement, is it clear,
Yes.
everyone?
Yes, sir.
Yes, sir.
Okay.
Yes.
Thus, it results in a triangle of the forces by the shown in figure. So whatever I have said here, everything is shown in the triangle. Okay. Now, the external angles at A, B, and C equal to beta, gamma, and alpha. A, this is a A point. एक्सटर्नल एंगल कितना है बीटा, यस ए के जगह पे बीटा आ गया है। देन बी की जगह पे कितना है गामा, बी की जगह पे कितना है गामा, करेक्ट। देन सी की जगह पे कितना है, दिस इज सी, सी की जगह में अल्फा, सो सी की जगह पे इट इज अल्फा एक्सटर्नल एंगल। आर यू गेटिंग ऑल ऑफ यू?
Yes.
Yes,
Yes.
sir.
Yes. And then if this is a exterior angle, एक straight line है तो if this is the straight line, the interior angle कितना रहता? This is 180 degree.
180
Okay. So if this is the exterior angle beta, then interior angle will be 180 minus beta. So at B, if this exterior angle is gamma, interior is 180 minus gamma. Okay. So and respectively हो गया ए बी बी सी सी ए, इट इज ए बी कितना है F1 फोर्स, बी सी कितना है F2 फोर्स, सी ए कितना है F3 फोर्स, so respectively F1 F2 F3 respectively. Is it clear everyone?
Yes, sir.
Yes, sir.
In the above triangle ABC, this is a triangle ABC, AB is equal to F1, BC is equal to F2, CA is equal to F3. By applying sine rule to the triangle ABC, हाँ tell me.
ये जो वेक्टर डायग्राम है आपको हमने वो स्पेस डायग्राम से डिराइव किए है क्या?
Yes.
ओके।
हाँ इधर से स्पेस डायग्राम से डेरा किया, ओके। नेक्स्ट, सो एज पर द साइन रूल, अकॉर्डिंग टू साइन रूल क्या बोलते हैं, मैथमेटिक्स में साइन रूल था ना, दैट इज ईच साइड इज डायरेक्टली प्रोपोर्शनल टू द साइन ऑफ द एंगल मेड बाय द अदर टू साइड्स, करेक्ट। एज पर द मैथमेटिक्स साइन रूल, ईच साइड इज डायरेक्टली प्रोपोर्शनल टू द साइन ऑफ द एंगल मेड बाय द अदर टू फोर्सेस। ए साइड है ए बी के साइड अपोजिट कौन सा है, दिस इज द एंगल, करेक्ट। AB के साइड अपोजिट इज दिस, सो AB डिवाइडेड बाय अपोजिट एंगल कितना है 180 माइनस अल्फा, AB डिवाइडेड बाय AB मींस हाउ मच, AB मींस F1, AB मींस F1 डिवाइडेड बाय sin of 180 minus alpha. Okay, so here you can write one more step if you want. Okay, what you have to write, so that is according to sin rule we get AB divided by sin of 180 minus alpha. This is equal to BC divided by sin of 180 minus beta, and this is equal to CA divided by sin of 180 minus gamma. Is it clear? As per this mathematics diagram, each side is directly proportional to sin of the angle made by the other two sides. Okay, so this is as per the diagram sin rule. Okay, then AB means how much? AB means how much? It is
सर जरा
F1.
बताइए।
F1.
F2. BC means how much? BC means how much? It is F2.
F2.
CA means F3. Okay, we know that from the mathematics, sin of 180 minus alpha is how much? It is sin alpha. Okay, sin of 180 minus beta is, it is sin beta. Sin of 180 minus gamma is, it is sin gamma.
Fine.
So F1 divided by sin alpha is equal to F2 divided by sin beta is equal to F3 divided by sin gamma. This is entire derivation as per the Lami's theorem. Is it clear, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Is there any doubt? किसी को doubt है क्या?
No, sir.
No, sir.
Okay. So have you started solving the assignment questions?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yesterday I have received so many questions. Okay. That is what are the laws of mechanics? What are the laws of mechanics? Can anybody tell me?
Newton's law, Newton's law of transmissibility,
Gravitation law, conservation of energy.
parallelogram law.
Yes, so laws of mechanics means what? मैंने ऐसे नहीं दिया था, मैंने directly Newton's first law, second law ऐसे दिया था. So when it is asked in the Newton's law of motion, so many people have messaged me, sir, what is
Sir,
this?
statement लिखिएगा फक्त.
क्या?
Statement
Yes,
लिखिएगा.
just write the statement because it is for 4 marks or 5 marks. Just write the statement. Newton's first law, second law, third law, gravitational law, law of transmissibility, law of parallelogram. Okay, so 5 to 6 mechanics laws you can write. Okay, so I'm happy that all of you are giving response, okay, through the telegram and through the WhatsApp. So many people are asking doubts and all. Okay, so if you have doubt in the class also, you can ask me in the class. Okay, अभी देखो इधर किसी भी आपको doubt है तो आप पूछ सकते हैं. I'm happy to explain 1 time नहीं 10 times also I'm ready to explain. डोंट गेट स्केयर, ओके। मैंने क्वेश्चन पूछे तो सर हमको डांटते हैं, सर कुछ तो ऐसे मत सोचो। हियर वी आर देयर टू टीच यू एंड हियर यू आर देयर टू लर्न। वो कितना भी डिफिकल्ट है तो भी आप पूछ सकते हैं। इनकी इस क्लास में आपको समझ नहीं है तो सो whenever you are free evening time you can call me and you can clarify your doubts also. Okay, so whoever has texted me through the Telegram or WhatsApp, I have replied. Most of the people I have replied. Even though if I have not replied, again do message. Okay, I will do reply to your question.
ओके
Have I
सर।
replied? Have I replied or not? मैंने reply किया क्या नहीं?
यस सर किया था।
Maximum students को मैंने reply किया था. 1 or 2 I may not be. Okay, so if I have not replied, you can again message me so that I will give you reply. Okay, everyone, is it clear?
Yes, sir.
Okay, so
Yes, sir.
so now in this chapter we have seen the equilibrium and also we have seen the Lami's theorem. Okay, sir, what is the advantage of Lami's theorem? Where we can apply the Lami's theorem and where we cannot apply the Lami's theorem? That we will see. Have you written all these things?
Yes.
Yes, sir.
Okay, is it visible PPT?
Yes, sir.
Okay, so limitations. Before going to the limitations, I will show where we can apply the Lami's theorem. Okay, see the diagram. Is it visible diagram?
Yes,
Okay,
sir.
the person is
Yes,
sitting
sir.
here, boy is sitting here. This is one force. Okay, this is one force. Wait, I'll draw the figure. So this is one force and this is one more force and iska weight kahan par aate? This is one force. How many forces are there here? 3 forces. You can apply Lami's theorem. See, there is a cylinder. It is hanging between two ropes. This one, this is one. This is one. Wait. So there are 3 forces. You can apply the Lami's theorem. See, there is what you call it is. क्या बोलते हैं इसको मराठी में?
गुल्ली डंडा.
Okay.
लगोर ते सर वो
ऐसा क्या? हाँ ठीक है. I don't know Marathi word. So here there is one cable. Here there is one more cable, and he is applying force here. Correct? He is applying force here. It is you can apply the Lami's theorem here also. See here, it is crane. Okay, this is one force. This is one force, and weight is acting here. You can apply Lami's theorem here also. Okay. These are some of the practical examples where you can apply the Lami's theorem. Okay. Okay, next, sir, what is the limitation? Limitations where we cannot apply the Lami's theorem. Okay, the first thing is कहाँ पर apply नहीं कर सकते means, so it is this theorem is applied only when the body is in equilibrium. The body should be in equilibrium. Okay, it should be in rest or it is continuous motion. Right, so we can apply. If it is not in equilibrium, we cannot apply this theorem. Clear? The body should be in equilibrium.
Sir, मागचा
क्या?
background sound.
Background noise, background noise.
बहुत डिस्टर्ब करतो सर मध्ये मध्ये.
There is one more class is going on and this cabin. Okay, today due to another script class, it is adjusted here only. We'll see. अभी डिस्टर्बेंस है क्या आपको? आपको डिस्टर्बेंस है क्या?
नहीं कोई बात नहीं सर.
हाँ ये आ रहा है ना? ओके, इसके लिए मैंने थोड़ा लो वॉइस में बात कर रहे हैं. Okay, this theorem is applied for the when body is in equilibrium. Correct. Next, it
Yes.
cannot be applied when less applied when less than or more than 3 forces. The force must be कितना रहने का? कितना forces रहने का? There must be 3 forces. If there are only 2 forces, we cannot apply this theorem. If it is more than 3 forces, then also we cannot apply Lami's theorem. This is the disadvantage